Okay, so what I want to do is look at the packet again and go through with you the important key concepts. So, an asymptote on page I. We have several asymptotes, and yesterday when I was going over vertical asymptotes, you're kind of like, we know these, we did these. So vertical asymptotes are any output after the problem has been factored that is still going to create a zero in your denominator. So a vertical asymptote comes from a denominator equaling zero after the whole problem has been simplified. So I'm going to be writing a lot of cursive because it's easier with this pen. So putting on no cursive. Or what I call print and cursive kind of. Now, horizontal asymptotes are a little bit different. They have a little bit more to take into account. So horizontal asymptotes are when you compare the degree of the top to the degree of the bottom. A vertical asymptote, and I should have put this, is always x equals and then your number. A horizontal asymptote will always be y equals and a number or a linear equation. The horizontal asymptotes are y, vertical asymptotes are x. So then there are three different kind of cases for horizontal asymptote. You have a slant, you have a case where it's always zero, and you have a case where it's equal to a number. So if the degree of the numerator equals the degree of the denominator, then a horizontal asymptote is the coefficients of each. And what I mean by that is that, let's say you had 5x squared minus 3x over top of 4x squared, then it would be the 5 over the 4 for your y equals. So that's like example 1. So example 1 on that page gives you an example where there's a horizontal asymptote where the degree of the numerator and the degree of the denominator are the same. Example 2 is a case where the degree of the numerator is smaller than the degree of the denominator. If the degree of the numerator is smaller than the degree of the denominator by 1, only by 1, then your horizontal asymptote is y equals 0. If the top is greater than the bottom, then there is none. The top is greater than the bottom, then there is none. If the bottom is by more than 1, then you have a slant and you have to do long division, and we're going to look at that next week. So there aren't any of those, I believe, on this handout. Yes. Oops. Just forgot to next slide. All right, so then the next part is exponents. And exponents and simplifying exponents is a big part of what we're going to look at this year. We do a lot of fractional exponents. We do a lot of fractions where we're subtracting or where we're multiplying exponents that are fractions. We do a lot where we convert a square root to a power. So in here, anytime you have a radical, whether it's a cube root, a fifth root, a square root, we are always going to convert our radicals to exponents. So in here, you are always going to take a radical and turn it to an exponent. So like a cube root is x to the 1/3. A fifth root is x to the 1/5. A square root is x to the 1/2. So whatever is like in the radical as the nth root becomes the bottom of the fraction. If you have a variable underneath those other than x, then that changes the numerator of the exponent. So if you had the 6th root of x to the 11th, then it becomes x to the 11th over 6. I don't care if it's an improper fraction. Now, if it's something that simplifies nicely, you should simplify it. The other thing we're going to do is look at negative exponents. Negative exponents are a no-no. So again, negative exponents are a no-no. You have to turn all negative exponents into a positive once you are done with the problem. So you can leave them as negative in the problem, but once you get to the final answer, you need to make them positive. So again, if you can't recall, that means x to the negative n is equal to 1 over x to the n, and vice versa. If you have two exponents being multiplied, we add them. So x cubed times x to the 6th is not x to the 18, it is x to the 9th. Because the rule is that it's x cubed plus x to the 6th. X cubed to the 6th power is the multiplying version, and that's where you get x to the 18. And then division, so it'd be like x cubed over x to the 6th becomes subtraction, and it's always top minus bottom. So you get x to the negative 3, and again, no negative exponents. So you rewrite that as 1 over x cubed. This is why we do domain and range. it's important to know that something like 1 over x cubed has a domain in which x does not equal what? What only number in the world can we divide by? 0. Let's do one of the ones on the next page. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 of you. We'll do 11. Oh, 11's easy. Never mind. Let's do 13. All right. So we have 1/4 16 x squared to the negative 3/4 times 32x. This is where it's really important to understand that multiplication is commutative. Multiplication is commutative. I can rearrange this problem so that I can group 32x and 1/4. The reason I want to do that is because 32 divides by 4. It's 8. So I've now simplified the outside. Now I got to work through the inside. This exponent here does not just multiply to the square. It also goes to the 16. So this becomes 8x times 16 to the negative 3/4 times x squared. A power to a power becomes multiplied to the negative 3/4. You can do either when you're simplifying. So that's 16. You do not need to cube it and then take the 4th root. You can think of that as the 4th root of 16, then to the negative cube. Why do I want to do that? Why is 16, the 4th root of 16 better than 16 to the negative 3 and then 4th rooting it? Correct? Yeah. No, not divides by 2. Be careful. So it's a root, right? So 16 is really 2 times 2 times 2 times 2, right? So 16 is really 2 to the 4th. So the 4th root of 2 to the 4th becomes 2. Does everybody follow that? Okay with that? Because the 4th power and the 4th root cancel each other, so you're left with 2. Well, now I just have 2 to the negative cubed. So if I follow this way, I have 8x times 1 over, we're going to bring that 2 cubed down. Why do I want to do that? Because it's a negative exponent. Bringing it down, what do you know about 2 cubed? It is 8. Oh man, goodbye, goodbye. Now I'm left with just x out in front. over here, you multiply those together. So we know it's going to be x. 2 times 3 is negative 6 over 4. Well, negative 6/4 becomes negative 3x. So now, go back to those rules, right? Two x's being multiplied times each other means that we add the exponents. So 1 plus negative 3/2 becomes x to the negative 1/2, which becomes 1 over x to the 1/2, or 1 over exactly the square root of x. But remember what I told you, we don't like radicals. So I would stop here. This is unnecessary work. You don't need to go there. There's not even an eraser on this little whiteboard. That's why I keep scribbling on stuff. The only delete key deletes everything. I don't remember what I told you to stop at. Today, like yesterday was through H. Today is K, or I through something. I through P maybe. I feel like I'm losing you. All right. It is a lot of work. That's why I usually do this in the summer. All right, so complex fractions are not as bad as they sound, but they're like the math you have to be cautious of. So if you have a fraction over a fraction, so we'll say we have a over b divides x over y. You got to get rid of a fraction and a fraction. Those are no-nos. So you're going to multiply by y over x and y over x. So a divides b over x divides y is really the same as, a divides b times y over x. And that's something you kind of want to memorize, because doing this step here is going to cause you a lot of grief, because it's going to add that extra line. So let's go and look down at, well, I'll be nice. I'll do one of the examples on the other page. So let's do number 5. Okay, that's what I thought. Actually, I'll do 6, because 6 is even worse than 5. Okay, K6. So you have x to the negative 1 plus y to the negative 1 all over x plus y. So first thing you want to do is get rid of those negative exponents. Get them out of there. So you want to transform this so it's 1 over x plus 1 over y all over x plus y. What do you know about adding fractions? What do you need? In order to add fractions, what do I need? Same denominator. Thank you, Miss Mel. So I need a common denominator. That means this fraction here needs a y. This fraction here needs x. So in order to get that, you got to multiply by y over y and x over x. So now I have y plus x over xy all over x plus y. Using that rule from the previous slide, this is like a fraction over a fraction. There's your a over b times x over y. This is like over a1. So you're going to flip the bottom and multiply it by the top. So you get y plus x over xy times 1 over x plus y. Yes, because addition is commutative. So y plus x and x plus y are identical. So they cancel. So we get 1 over x plus y. What? I know, I feel like I'm not going to go all the way through P. I feel like we're going to take our break in the middle. Yes. It shouldn't be, thank you. That should be x times y. Good catch. All right, we'll do one more page, then we'll go for a math break. Let's do L. L is not bad. You guys know how to do inverses. How do you find an inverse? What do we do? What's the formula or the step process? Exactly. So first thing you do is switch x and y. Yep, and then solve for y again. So you switch x and y, and then you solve for y. It gets a little bit trickier when it's not linear. So let's look at a non-linear inverse. Because what do you know about an inverse? In order for it to exist, the function needs to be what? In order for a function to have an inverse, you need what? It needs to be what? Yep, good. Not odd. It's actually 3 words. I mean, odd sometimes doesn't have to be odd, though. It can be odd or what? What did you say? It's has to be 1 to 1. So a quadratic, by definition, does not have an inverse. A quadratic only has an inverse on a restricted domain. Quadratic only has an inverse on a restricted domain. So the domain either has to be the right side or the left side. And the domain's going to come from which one becomes true. So the inverse of a quadratic, so like I'll do L. Yeah, that's annoying. It should be number 3, but it's letter C. This one is y equals 9 minus x squared. So that quadratic opens down like a frown and is shifted up 9 units. So it kind of looks like this. Switch your x and y. Solve for y.
Justin, weekly, please report to the office.
How do you get rid of something squared? Square root. So again, the positive would go to this side, and then the negative, and that's where the plus or minus comes into play. So like the positive square root would account for one side of the quadratic, and then the negative would account for the other side. And then if you restricted your domain to be x greater than or equal to 0 or x less than or equal to 0, it would be true. Okay. Once you're done copying that, we'll go take our mask break. I feel like I'm losing you. All right, so for letter M, we are adding and solving fractional equations. This is really kind of like complex numbers, but now you're solving. So now you are, instead of just leaving it as a fraction, you are solving for your variable. Let's look at, I don't know, number 3. Let's look at B. So, well, 3A and 3B go together. So 3A is creating the common fraction. 3B is then solving it. And honestly, if you don't need like the 3A side, you don't have to do it. It's just combining the left side to simplify the right. So in 3A, what we're going to do is say our LCD, the least common denominator, is 2x times 3x plus 15. So once you have a least common denominator, you have to multiply both sides by that LCD so that you can combine like terms. So you have 5 over 2x. So out of the LCD, this part needs the 3x plus 15. And then you're subtracting that 5 over 3x plus 15. So this part needs the 2x. We're going to distribute the 5 inside this parenthesis here. So we get 15x plus 75 minus 10x all over 2x times 3x plus 15. Combine like terms, 15 minus 10 is 5x. So that's part A. So for 1, 2, 3, and 4, part A is just simplifying the left side of the fraction. For part B, I'm going to take the answer I got in A, so that 5x plus 75 over 2x times 3x plus 15. And what we're going to do is set it equal to the other piece that was already there. So in this case, it's now equal to the 5 over x. What can I do with this type of problem that makes this now easier than trying to do it the other way and getting an LCD of both sides? Yeah, so that's called, when you have like this simplified, oops, what did I write? This is called what method? Yeah, cross multiply. We're going to cross multiply. It's going to be a lot easier than trying to get an LCD of all three parts. So you get 5x squared plus 75x equals 5 times 2 is 10x times the 3x plus 15. And then we're just going to distribute, simplify, and stop. So you factor out a 25x, you get x plus 3. So then we get x equals 0 and x equals negative 3. Now, what do you know about x equals 0? Back to the original problem in part B. Go ahead, I didn't hear you in your mask, I'm sorry. Yeah, it's an extraneous solution. X can't be 0. It's not part of the domain. So you have to make sure you know to cross that out. You need to know and understand your domain before your solutions. Go ahead, quickly, what's up? Yes. And I love that you use the word extraneous solutions. They're a big part of the very next letter we're going to talk about, which is n. N is on absolute values. Absolute values have extraneous solutions. The easiest way to see an absolute value with that type of solution is when you simplify and you get an absolute value is equal to a negative number. Can an absolute value ever be equal to a negative number? No. Like, an absolute value is always positive. It represents distance. Distance is positive. Whether you're moving forwards or backwards, the distance is positive. So an absolute value can never equal a negative number. So let's look at N3. Because N3 gives an example of both working and non-working. So we have the absolute value of 8 plus 2x absolute value plus 2x equals 40. Step 1 when solving an absolute value problem is to isolate the absolute value. Isolate the absolute value. So we're going to subtract 2x from both sides. Once the absolute value is isolated, you split the problem. So it's 8 plus 2x equals 40 minus 2x. And then the opposite side is 8 plus 2x equals negative the entire part of 40 minus 2x. And then you solve for each separately. So over here, you'll subtract 2x from both sides, subtract 40 from both sides. So we get negative 32 equals negative 4x, or x equals 8. A quick plugging in, I see that this is positive. 8 times 2 is positive. This is positive. It's going to work. Once my algebra is bad, I don't need to know if the actual 8 plugged in works. I just need to make sure the signs work. Over here on this side, you get 8 plus 2x equals negative 40 plus 2x, because that negative distributes to both. But then, when I subtract my 2x from both sides, I get 8 equals negative 40. Does 8 ever equal negative 40 by itself? No. So that's a no real solution type concept. So this part just doesn't work. So x equals 8 is my only valid solution. Okay, and then letter O. O is for inequalities. So you guys would have looked at these last year. Inequalities oftentimes involve sign charts or number lines to understand where solution sets lie. So inequalities and solution sets often come from quadratics and absolute values. So if we take that same idea of an absolute value back into play, we can look at example number 4. So you have x plus 7 greater than or equal to absolute value 5 minus 3x. We're going to split this the exact same way we just previously split our absolute value. And I like to see it with the absolute value on the left. So really this is kind of like saying 5 minus 3x inside an absolute value is less than or equal to x plus 7. I think that's more logical. So then when you do your split, you see 5 minus 3x less than or equal to x plus 7. But you also need to see 5 minus 3x. And with an inequality, when you split an absolute value, you have to change the direction of the inequality, as well as making everything on the opposite side negative. So it'd be negative x, negative 7. Go ahead and solve for x in each of those. I'm not going to talk through it. I'll let you think through it on your own. And then what you have to do is just check. So this side, it's x greater than or equal to negative 1/2. And over here, it's less than or equal to 6. So again, this is a less than, so and you can see when you graph it on a number line, it's an and problem. Less than is and, so you can see it on the number line. Right? Or is or. All right, the last page is all about exponents and logarithms. This page hopefully isn't too bad, but here's what we're going to do. You guys are going to stop after the example 1. So in terms of this packet and turning into me, you guys do not have to do part 2 of page P. We're just doing problem 1. So you can put a big X at the bottom of page P number 2. Because that takes a lot more in-depth learning, and I don't know what you actually did with logs. Did you even do logs?
I think we had like a day or two.
As I said, I think you guys can do all of the top because it's simplifying. I'm afraid you don't know how to do any of the bottom. The top is just rearranging. So the top, you can do the top. The top is, honestly, you're just using this formula right here. You're going to use the log base A of B equals y. And then you transform it to say y of A equals B. So like anything, if it was like a problem, you can switch it from log to exponent or exponent to log. It's important to remember that the natural log of E is equal to what? 1. They're inverses of each other. If you have the natural log of e to the x, it would be equal to x. And if you have any natural log of, like, let's say a to the b, that power can come out in front, so it becomes b times the natural log of a. So a natural log to a power brings the power out in front. If you have the, like, let's say log of 4 to the a minus log of 4 to the b. You guys know you can rewrite that as log of 4 to the a divides b. And if it is addition, it's like log of 4 to the a plus log of 4 to the b. That is the same as log of 4 to the a times b. Seriously? I did this with my advanced algebra 2 kids.